Good morning. All right, today is lesson 149, and I forgot the page again, 269 and 270. I also noticed that I've been recording and forgetting to change my date. Did any of you catch that? I didn't until just now. I was 2 days behind. It's crazy. And of course, you're watching it the day after, so you're watching it on the 16th. It's all crazy. It's all good. So let's do some quick review. We'll get rid of my marker. Let's change some fractions into decimals, okay? We'll do this one last. You should have 0.16 with the bar over the 6. Remember, both of these digits appear in there, so that's easy. 0.6 repeating. Anytime we have thirds, it's going to be that way. So 0.3 repeating. Okay, then when we have our eighths, 0.875. Remember, we're always going to have 3 digits when it's eighths. 0.625. 0.375 and 0.125. Right, so watch out for those eighths. They're always going to have either a 2.5 or a 7.5 at the end. So if you remember, like this is 0.125, then you're going to have a 0.375. It goes back and forth. 0.625 and then a 0.875. So it's always going to have a 2.5 or a 7.5, and it goes back and forth in the order that it does it. All right, then some easier ones. 0.8, 0.6, you should know these. 0.4, because 1/5 is 0.2. 0.75, that one should be automatic. 0.25 and 0.5 or 0.50. I know some of you on your quizzes will put 0.50, some of you put 0.5. Even if the online quiz ones will take off because I didn't put a 0 or did put a 0 in the answer, I go back and give full credit. It's the same thing. All right, reviewing this, what does this temperature represent? If you remember from yesterday, we learned that this is the Celsius temperature for your normal body temperature. Celsius temperature for boiling point of water, and the Celsius temperature for the freezing point of water. So we went over these yesterday. It's a good idea to commit them to memory. This you should always hear, because if you've got fevers or anything, this is the temperature your mom is looking for, 98.6. It doesn't mean everybody is exactly this. This is the average body temperature in Fahrenheit. Boiling point of water in Fahrenheit, and then the freezing point of water in Fahrenheit. 5.6. It is 0.83. I forgot that one with a repeating 3, so I need to memorize that one better. 5.6 is 0.83. Do you remember the formula we used yesterday when we were converting from Fahrenheit to Celsius or Celsius to Fahrenheit? We were using Celsius to find Fahrenheit. Okay, remember it's 9/5 times C and then plus 32. We followed the order of operations by multiplying, and then we added 32 to get our Fahrenheit temperature. So let's test one to see if you're remembering that correctly. So let's go ahead and convert 33 degrees Celsius. So if we're putting in the formula, man, this cap does not want to come off. There we go. So we've got 9/5 C, which means we're multiplying, times 33. I'm going to go ahead and make it a fraction. And then we have to add 32. Now here's one where it's not necessarily going to be able to cross cancel and work out evenly, and that's fine. We can do 33 times 9. Right. We get 297 over 5, and then we still have to add 32 degrees. Well, let's simplify this. I know 5 won't go into 2. It will go into 29 5 times with 4 left over. It will go into 47. I just don't have room to divide it all out on this little box, but you can do it on your paper. It will go into 47 9 times, 45 with 2 left over. So we have 59 and 2/5 plus 32. Okay. I'm going to remove this and make some room up here. 33 degrees Celsius. We know we can add the whole numbers very easily and keep the fractions. So 59 plus 32 is going to be 91 and 2/5 degrees Fahrenheit. Okay, so even though we can't cross cancel, we can multiply. We can simplify this to a mixed number and then add the 32 to it. Okay, and we can have a mixed number in our temperature. Now, if they ask us to round this to the nearest whole temperature, is it going to be 91 or 92? 2, that's not half of 5. So if we are asked to round to the nearest whole degree, we could put 91 degrees Fahrenheit. All right, one last thing to review. Let's go over solving ratios. When it doesn't work evenly, 7 can't go into 9 as a fact that's automatic in my head. So we learned a method for solving the missing number. Do you remember what it is? Cross multiply, 7 times 25. All right, that is not quite 400. All right, am I right? 275, it's not quite 200. 4, 5, 6, 7. Let's multiply correctly, Mrs. Nightingale, that would be great. 175, and then what do we do with this? We divide by that number that's left. So 175 divided by 9, all right, it's going to go in once. Okay. So we could say 19 and 4/9. We don't put 19 remainder 4. So x equals 19 and 4/9. Or you could put a decimal point and a 0 and keep going 2 more spaces and round it to the nearest tenth of a decimal. But I just made it a mixed number. So 19 and 4/9 is the value of x. All right, let's get into today's lesson where now we are taking the Fahrenheit temperature and converting to Celsius. Yesterday we did the reverse. So following along on your page, we noticed they give us a lot fewer facts because it was just a reminder yesterday of the different things that we know about temperature. What do we use to measure a thermometer? What is the unit? Degrees, that kind of stuff. All right, so the formula to convert from the Fahrenheit scale to the Celsius scale is C equals 5/9 times everything that's in parentheses. So they don't have to put this. Okay? They can just squish it together right next to the parentheses because we've learned that parentheses mean multiplication. And then, of course, on our order of operations, we're going to have to do this before we multiply this because it's 5/9 times this stuff in here. So we've got the parentheses, which is a very important part of this formula. 5/9, so notice the fraction is flipped, times, and then we've got parentheses, f minus 32. So instead of adding 32 when we're converting the other way, it's minus. So you will have to make sure that you keep track of the differences of the two. One is 9/5, and then we're adding 32, that's when we're finding Fahrenheit. Today is 5/9, but we're subtracting the 32, and we're changing the order. That's what the parentheses is. We're subtracting first, then multiplying. Yesterday was multiplying, then adding. All right, so everything is reversed when we're talking about changing from Fahrenheit to Celsius. We're still going to plug it into the formula. C equals 5/9 times Fahrenheit. Well, they give us a Fahrenheit degree, 86, and then minus 32. This is what we need to do first. Remember PEMDAS? P, parentheses. It's the very first thing. That is what we solve first. So we still have our 5/9. But 86 minus 32 is 54. That's what I'm going to multiply by. And I'm going to go ahead and just make it a fraction because I know that's coming. So 86 minus 32 is where we get 54. I made it into a fraction so that I can multiply. This one, I'm able to cross cancel. And 5 times 6 gets us 30 degrees. So a way of checking yourself is always your Fahrenheit degrees, or your measurement or your temperature is always going to be greater than the Celsius. So if you've come up with an answer that's higher than this, you are way wrong. It's always going to be lower Celsius value, higher Fahrenheit value. And you can even remember that because in alphabetical order, C comes before F, A, B, C, D, E, F. So this temperature will always come first in order. 30 comes before 86, Celsius comes before Fahrenheit. One more here, same formula. 5/9 times F, right? 122 minus 32. And let's go ahead and solve. 122 minus 32 should be 90. We subtract first because it's in parentheses. Then we're left to multiply that 5/9 by the value that we found here. We can cross cancel. And 5 times 10. Don't forget your degree symbol. 50 degrees Celsius for that 122 degrees Fahrenheit. So section 1 under class practice, convert those temperatures from Fahrenheit to Celsius. Go ahead and do all three, and then let's check answers. All right, hopefully you converted all three of them. You should have gotten A as 40 degrees Celsius. You had to subtract 104 minus 32. That gives you 72. And then times 5/9. All right, B, 10 degrees Celsius. And C, you should have gotten 80 degrees Celsius. Number 2 is the same thing. It just gives it to you in word problem form. You can do that. Number 3, this section is converting from Celsius to Fahrenheit. So now you're going back to this formula that we used yesterday. Do A and B. Using this formula, they've given us Celsius. We have to find what does it equal to Fahrenheit. So we're not using the new one. We're going back to yesterday. All right, that should have given you plenty of time to pause, come back, checking these answers for A and B only, then you're going to finish the rest on the section. A, you should have gotten 77 degrees Fahrenheit, okay? And then B, 75 degrees Fahrenheit would be the closest whole temperature, because look at the direction, give the temperatures to the nearest degree. All right, C, D, E, and F, you're on your own, and you'll turn in these to me by Monday. Number 4, section 4, you're solving for X. Make sure you watch your steps. Notice they've got a proportion in there for us, okay? And they have a couple two-step equations as well. On the back page, page 270, the only section you're going to do on the back is number 9. So we're not going to do 5, 6, 7, or 8. 5 is finding more areas and perimeters. We keep doing those reviews. You can skip that for today. 6, you don't need to complete the chart. We don't often convert to acres, so don't worry about that. And then 7 and 8, we skipped in those lessons since we've been homebound. So number 9, I want you to complete all of them by following the directions, but you may skip 5, 6, 7, and 8, and that is in the directions for you as well on your assignment list. So that's it for today's lesson 149. And then tomorrow we'll just do some brief temperature review as you get going with that. And you will have a math quiz coming up again in about a week and a half maybe. So practice, use the formulas, write them down. I will expect you to use them on your quiz when it does come up. So you need to know, when do you use this formula and when do you use this formula? And I expect you to be able to use them, but you don't have to have them memorized anytime we do quizzes or things through Homebound. All right, so that was it for today. I miss you guys, and I wish you were here for the math lesson, but hopefully this is helping you and easier to understand rather than just reading it on your own. And I wish I could teach you in person, trust me. But have a good day, keep working hard. I'm really proud of you guys. I'll talk to you later. Bye.